Yo, what's up guys? So today we'll be talking about exponential models. But first I would like to say that I'm, trying to grow my YouTube channel, and if you guys are enjoying this content and want to see more, consider subscribing. But, let's get into the video. So the first thing we're going to be discussing in this video is interpreting the rate of change of exponential models. So rate of change, okay? So you guys may recognize rate of change, and you're like, oh, well, that's slope, right? But in this case, we're talking about exponential models. So on a graph of, if you were to graph these exponential models, instead of looking something like this, right, they may look something like this, okay? So they're not increasing by a constant rate, but instead at an exponential rate, okay? So we'll talk about that in a second, okay? So this is, it's very simple. So it's basically just looking at an exponential function and determining whether or not it is growing or shrinking, and by what factor. So normally you'll see exponential functions in the form a times b to the power of x, okay? So if b is less than 1, so if b is less than 1, then we know that it is shrinking, okay? So I'm just going to put an S, okay? And if b is greater than 1, it's going to be growing, okay? And obviously if it's equal to 1, it's going to be constant, because 1 to the power of anything is still 1, okay? And also by the factor, it's just b. b is the factor by which it is either growing or shrinking, okay? So that's really it. So let's do some examples. How about we say 32 times 3 to the power of t, okay? And 25 times 0. How about we do 1 half to the power of 3t, okay? Let's look at these functions and determine whether they're growing or shrinking, and by what factor, okay? So let's look at this first one, okay? 32 times 3 to the power of t. So let's just let's look at our little chart over here. So is 3 less than or greater than 1? It's obviously it's greater than 1. So we know that this function is growing, and by what factor? Well, like I said, the factor is just whatever b is, so by a factor of 3, okay? So now let's look at this one. 25 times, I just tried to do parentheses, that's bad, parentheses, times 1 half 3 to the power of t. So is it growing or shrinking? Because right here, is 1 half greater than or less than 1? It is less than 1, right? So we know it is shrinking, okay? And by what factor? Again, it's just whatever b is, right? So we know that it is shrinking by a factor of 1 half. So quickly, before we continue the video, I just want to get out of the way the different parts of exponential functions. So let me fix that right there. So let's look at this part. Let's look at the form a times b to the power of x. So x obviously is the variable, b is the factor by which you multiply, and a is the base or starting point. No matter what b or the exponent is, whenever x is equal to 0, f of x is equal to a, okay? And now let's just say that it's just 1x, okay? So there's nothing, it's just x. There's no other things that x be multiplied by, okay? So when x is equal to 1, it's going to be equal to a times b to the first, right? And 2 is going to be a times b twice, or a to the second, okay? And 3 is a times b to the third, okay? So now let's work on another function, okay? Let's say that we have a times b to, how about x divided by 3, okay? So let's call that g of x, okay? So if we set up our little model right here, we have g of x, then obviously when x is equal to 0, g is equal to a, okay? Now, when x is equal to 1, it's going to be a times not b to the first, but b to the 1/3, or the cube root of b. And same thing, 2 is going to be a times b to the 2/3, and 3 is going to be a times b to the first. So look at that. So it takes x being equal to 3 for g of x for it to be equal to when x is 1 for f of x. Now let's do one more. How about we have h of x, okay, of another function, and we have a times b to the 3x, okay? So obviously when x equal to 0, it's equal to just a, right? When x equal to 1, it's equal to a times not b to the first, not b to the 1/3, but b to the third, okay? And with 2, it's going to be b to the 6th, and with 3, it's going to be a times b to the 9th. So I just wanted to get the different parts of exponential models and functions out of the way before we continued the video. Next, we're going to be constructing exponential models. So let's take some words and make it into an equation. So we were able to look at some exponential models, we did some examples, and we were able to determine if it was growing or shrinking and by what factor, okay? So now let's do some examples, okay? We'll take the words and we'll make it into an equation, okay? So let's say that we have a bacteria population of 30, okay? And try to work these on your own. So we have a bacteria population of 30, and it doubles every 3 days, okay? So how can we do this? So let's work this one out. So we know that our base is going to be 30, right? So we know at 0 days it's going to be just 30, okay? Times what? Well, let's do some examples. Okay, well let's define our variable as, how about d, okay? D is the number of days, okay? So we'll just have a little chart right here, and then f of d. Sorry, that's about f. And we're like, okay, well if we know that, okay, let's say 0 days. At 0 days, it's just 30, right? Because it's starting out. Okay, well if it doubles every day, or sorry, every 3 days, then we'll know in 3 days it will be 60, right? So it's being multiplied by a factor of 2, factor is keyword here, every 3 days. So how do we write that 3 days in as an exponent? Well, we know that's multiplying it by 2 to the power of 1 every 3 days, when d is equal to a factor of 3, okay? So we can write this as 2 to the power of d divided by 3. So, let's test this out. Okay, well, let's say we're at 0 days. Well, if d is equal to 0, then it's 2 to the power of 0, which is just 1, so it's 30, right? And if we plug in 3, let's just plug in 3 real quick, times 2 to the power of 3 divided by 3, and we know that 3 divided by 3 is 1, so just 30 times 2, which is 60. So right here, that's our equation. That's our equation for this growing bacteria population. Okay, thank you guys for watching. So I had to cut the video a little short today. Again, next video we'll pick up working with some more examples and some more advanced interpretations. Peace.